and welcome again to Teen Learn Mathline. We are so glad you tuned in this afternoon. I'm your host for the 8th session, Ernie Roberts. And again, as I said, we are so glad you've tuned in to watch us this afternoon. We've got a great episode of specialized segments coming your way. Now, what do? You get that pencil, get that paper ready. Let's work some problems together. And we're going to have a little help and a little assistance today. This is going to be kind of fun. The students from Miss Celeste White's math class at West High School here in Knoxville, Tennessee, Knoxville West, will be joining us sporadically, giving us a few problems and such for us to work out together. So hang with us, enjoy it. They're a great bunch, and I think you're going to have a good time with us today. So we're glad you tuned in, and let's see kind of what the storyline is. I believe we're on the road, are we not? Yes, on the road with Knoxville West High School. And what we do, folks, when we get on the road with the school, we go out and visit that school, and we pick a few. If we don't pick, they get to volunteer, do whatever they need to do, and they come and give us some problems and work with it. So if your school would like to do that sometime, your high school or your middle school or your elementary school, we've been to Beaumont Magnet here in Knoxville. We've also been out to Kingston Elementary. There are just a lot of places we can go, but you just need to let us know that your teacher and you would like for us to come visit you, all right? We'll be glad to do that. And hey, you could appear on Mathline like in person, all right? So we always love it when you talk. But today's not one of those talking days, not one of those days you get to call in. But we'll be back again, all right, the next time for that situation. But today, let's enjoy what West High School has to offer. Now, we're going to be talking about linear equations. That means the graph is a straight line. So let's go to the calculator here just a minute. I want to go back and refresh your memory on what a straight line, what kind of things goes along with. We have a thing called Slope-Intercept Form. So we're going to go to our y equals key here. All right, there it is, y equals. And we've got some various ways that we can graph a few things in there. We worry about slope and intercept. Now, I'm going to go ahead and use slopes that are not zero today, all right? You can have zero slopes, which make nice horizontal lines. But what we're looking at here are the situation, those situations we're going to have a little bit of diagonal look, all right? Not just a flat horizontal, but more of a going in a negative or a positive fashion. Speaking of which, let's take a look. It's 2x, all right? Just pop it in there, y equals 2x. And we'll put an enter on that, and we'll graph. See what it looks like. It's going to come out in blue. And we said it's supposed to be a straight line. That looks pretty straight line to me, all right? We can put a trace on that, see what kind of points make up. There's the origin. 0, 0 works great on this line. What happens if I put how about it? Let's see. Put a 3 in there for x. Wow, bang, there it is. Hit enter. And we're at 6. In other words, 2 times 3 gives us 6. So this is what we call a linear relationship. It's where it patterns out. I could come along here. Let's go back to y equals. And let's put a 2x. And let's tack on something else. This would be, by the way, the intercept on that last one was 0, in case you were wondering. Let's put a minus 4 on there so this spreads out just a little bit. And let's keep our 2x in there while we're at it. Why not? Let's keep 2x back there. Sorry about that. Got a little carried away and lost it. And here we have it. Let's see what those two lines look like together. We enter and we graph. And there goes a blue line. And here comes a red line. Looks like they look parallel. They are. They never intersect. They have the same slope. Okay, so that's going to be a key to one of our problems that we've got later on today is, what happens if the lines are parallel? Well, they're going to have the same slope. Just a few things to remember. By the way, the intercept on that second one right down there, the first one, that blue one, is -4. Intercept on 2x is just at 0, 0, the origin. So little things, little hints that y and slope-intercept, as we like to call it, that is the y-intercept, not the x-intercept. Notice they're happening too, but they're in a different ball game here, all right? We are talking about slope and the y-intercept of the lines. Let's put one more in the mix here. How about it? Let's put y equals. Kick down here just one notch. And I'm going to throw in -1/2. Now be sure you put a negative on that, all right? 1 divided by 2, that's how we write it. That's how we write a fraction here. Sometimes people get a little concerned about those fractions. They're divisions. And we have an x right there, and why not? Oh, let's just put a +2 on it. I don't know what it's going to do. We're going to see what happens, all right? It's going to give us an interesting looking graph because here's our third line. It's coming through black. So here we go. And if you'll notice, that pretty much looks like it's making some right angles through those lines, all right? And if we are on a zoom 5, and I believe we are, you say, what? Go to your zoom key right there. You see where I got it highlighted in red for you. And we zoom 5, which is a square. That will allow us to have the lines really look perpendicular. Otherwise, it's a little distorted because it's a rectangular screen and it tries to fit it, but this is the way you can get it to square out if you really want to see that nice right angle business right there. Look at those, beautiful perpendicular. By the way, that's because those are opposite reciprocals of each other. Also right here at the blue line intersecting the black, it's an opposite reciprocal setup. So these are some of the things we want to remind you of because these are some of the questions these folks from West High School are going to be asking us here on T and Learn Mathline. All right, so I think it's time for us to go right ahead and let's hear from our first student from West High School. See what we got going.
Got a math question? Mathline has answers. Hey, Mathline.
Hey Mathline, I am Juwan Moore from West High School in Knoxville, Tennessee, and I have a slope-intercept question for you. Could you find the equation of a line with slope of -2/3 passing through the point of 3, -6?
All right, Juwan Moore, thank you so much. By the way, Juwan plays basketball at West, and many of you may have seen his name and face occasionally in the newspapers when the teams are filmed or shot for the pictures and also for the news. So, Juwan, thanks for being with us today, and a great job there on that one. And he's got a good question for us. He says, if we have a slope of -2/3 and we want it to pass through 3 and -6, now how are we going to write that in, as he said, slope-intercept form? That's what we want. So we're going to find that equation of a line. We're going to do it in slope-intercept form, passing through the point 3, -6. All right, so first of all, let's talk about this. We are looking, by the way, slope-intercept form basically entails these ingredients. Y equals the slope times x plus the y-intercept. Now, I have a slope. I've got m. By the way, that's what m stands for there on those. I've got -2/3. I don't have a b. That's what I'm looking for. So we're going to look at this two different ways, all right? Two different ways here real quickly. We're going to start with the slope-intercept form, and what do we know? By the way, this is an ordered pair. This is an x. This is a y. I put 1 there, but it's the only one we got, right? So we'll just call it x and y. You say, Ernie, what's important about that? That's where we're going to find x and y from this point right here in order to find our b value, all right? So let's play the game. Let's see what's going to happen here. I know y, it's -6. Substitute it right in there, Juwan, all right? Over here, I've got -2/3. That's my slope. And then I've got my x value, which is 3. And then I'm going to tack on my little old creature b. All right, there we have it. Now, some of us get excited about the fractions. Oh my, I know. But you know what happens when we take 2/3 of 3? The 3's do cancel. That's why I put a 1 under that, so we'd see that. So this isn't so bad. It isn't bad at all. In fact, they cancel out completely, leave us with 1s. So I'm seeing -6 equals, it looks like -2 plus b. All of a sudden, this is a real easy equation. Actually, it wasn't that difficult to begin with, was it? But we start with the formula. How about that? Y equals mx plus b. And we plug in, we substitute what we know. What we know in m, we know x, we know y. If we know all 3 of those, it's easy to find b. All I need to do is move that -2 to the left. Let's add 2 to both sides. Oh, here we go. -4, that's what we have left. -6 plus 2. Basically, you're still in the hole 4. These say goodbye. We have b left over here, all right? So what does that tell us? That tells us the equation should be y equals -2/3 x minus 4. You say, Ernie, what happened to x and y? Well, that was just one option. Folks, there are infinitely many combinations of x and y that will make this a true statement, all right? We put in different x, we'll get a different y, all right? And it doesn't matter how many x's I want, I've got that many different y's that are going to go with it. So it's a function. That's why it works that way. So there's what we're ending up with. There's what we end up with. Now, I'm going to show one more option. This is a method that some of our teachers use, and I use it in my Algebra 1 and Algebra 2 classes. So it's called the point-slope formula. Now, I went straight from slope-intercept, and Juwan, we're still going to get to slope-intercept, all right, which is what you were asking for. It's just an optional way. It says y minus y1 equals the slope times x minus x1, all right? We know the slope, we know the y1, and we know the x1. Don't worry about this x and y back here. That's going to just filter out nicely, like we had to remove it here. But now we've got to incorporate it. This is, by the way, called point slope. form, all right? And you'll see that on pretty much your state test and whatever that formula is given to you, as well as this one, all right? Let's see what's going to do. We're going to take these points that we started with. Remember, y is with y, okay? Don't get the x and y mixed up. It's always ordered pair. Ordered means x comes before y, and there's two of them, all right? So let's go with it. We've got y minus a negative 6, you got it, equaling negative 2/3, and we've got x, looks like minus 3 on that one. And keep in mind, I put that minus a negative 6 there because that's what it is. That's what it is. So we're going to put plus, and we got y plus 6 equaling, we'll run this through here, distribute negative 2/3 x. We still got to run that through there, but it looks like it's going to be a plus 2, right? Okay, what's missing? What's missing, everybody? We got to get y by itself. We're almost at slope-intercept form. So let's kick it out here. We'll say subtract 6, subtract 6. I've got y equals negative 2/3 x minus 4. Is that what we said we were coming up with? That's what it's got here, what we got here. Let's do a real quick check on the graphing calculator and see if that works. All right, go to y equals. Let's put our negative. You say, how do you know if it's going to work? It's going to make a pretty straight line. We know that. But let's see how it works. Me and the trace button, you and the trace button. We all have the trace button. How about it? Let's put a minus 4 on that and see where that takes us. Graph it. And what I want to know is, does the point 3, negative 6 lie on there? Is it a member of this line? Because if it is, then I've got the right answer. We got the right answer. So let's go and trace, hit trace. See if my cursor will go there. There we go, trace. And it's giving me 0, negative 4, because it goes to the intercept usually when you hit the trace button, all right? The y-intercept goes right there, which is sweet because that's what we say it is. Let's see if that point 3 is going to work. So go hit 3, and automatically it takes you to x. That's the beauty of this. Hit enter, and we're hoping for negative 6. We get negative 6, means the answer is correct. So Jawan, there you have it. Your answer is y equals negative 2/3 x minus 4. And thank you for contributing to our show today, all right? Let's see what our next contestant on Mathline today, our next person from West High School. Come on in here, our next student, see what we've got.
Hey Mathline, I'm Haley from Knoxville West High School, and here's a problem for you to solve today. Find the equation of the line passing through the 2 points 3, negative 1/2, and 5, 1/2 in slope-intercept form.
Right, Haley, thank you from West High School here in Knoxville, Tennessee today. And we're going to find the equation of the line passing through those 2 points. So we've got 3, negative 1/2, we've got 5 and 1/2. Those are the coordinates. Those are coordinates. Now, some of you freak out when you see these fractions. I know sometimes I do too. I do too. We get a little upset and nervous, especially when they didn't give us a slope. All right? We've got 2 points, and what we're trying to do is figure out what is the equation of that line that's going to go right through those 2 points. And it's a unique equation, all right? Only one of its kind. So let's check it out and see how we're going to do. First of all, we've got to find the slope. That part we can do. And remember the slope in 2 words, rise divided by run. Rise over run, we like to call it. And the rise is the change vertically. All right, so here's what we got to do. Here's what we got to do, folks. We've got to take this one. I'm going to do 1/2. Well, I'm just going to write the formula down. Some of y'all like to see that. There's the formula. So many formulas, isn't it? And these are really some of the most important ones you have in Algebra 1, on up through the pre-calculus even. These still become important. We have a 1/2 minus a negative 1/2. Be careful, because some of you said, oh, it's going to get a 0. That's going to be real easy. Well, it's still going to be easy. But we're going to have to say plus a positive. All right? So we're going to have a 1/2 plus a 1/2, which does give us a whole, which isn't going to be too bad. Now, on the other side of the coin, I've got 5 minus 3. Now, notice what I did. I started with a second. Now, you say, does it matter if it's y1 minus y2 or y2 minus y1? No. But once you start with y2 minus y1, you've got to keep the second x and the first x the same pattern going. All right? You've got to keep in the same direction on that. Otherwise, you're going to have the wrong sign. You're going to be off by the wrong sign. So what do we got here? I see 1/2. So that's great. That's our slope. All right? Now, we got to pick a point. We just pick a point. All right? Either one of these, doesn't matter. Doesn't matter. So let's go. And I'm going to use the point slope approach on this one. I may regret this, but we're going to try the point slope on this. All right? Let's see what happens. Remember that formula is y minus y1 equaling slope times x minus x1. One of my teacher friends, Miss Leslie Howell, always called that the multi-purpose formula, and I love that. I love that thing because it works in a lot of ways. We can get a standard form, which gets us back to something like ax plus by equals c, or we can go to slope-intercept off of this thing. So let's put our numbers in that we've got. All right, we've got a point. We're going to pick the first point. By the way, either one of these will work because they are on the same line. So let's run it through here. How about it? Y is going to be y minus a negative 1/2. All right, it's using the first one. Equaling, oh, we already know that's 1/2 for slope, right? So there we go. And let's pick up our x, and we're going to put x minus 1/2 right there. Looks that way? Is that right? Everybody feeling good on that? Hope I am too. All right, let's see what we got. So we had 1/2 here, and we're putting in, no, we didn't put the right thing in there, did we, folks? Y'all catching me? That should be minus 3. Be careful. There's y, which is going to be y plus 1/2, by the way. We got y plus 1/2. Here, we're going to distribute that 1/2 through, and by the way, I'm using minus 3 because that's what we got there. So again, sometimes I switch up on you just to make sure you're with me, all right? We get kind of lazy there. We see all these halves, we just run halves everywhere, but that's not what we got there, okay? It's going to be minus 3. Let's see what happens now. We got 1/2 x, and we've got minus, how about it, 1/2 right there. Well, about 1/2? We could put minus 3 over 2. That's fine, that's fine. I like it that way because we're going to be looking for an intercept here, all right? Now, let's kick this 1/2 over. So we're going to take minus 1/2, minus 1/2. Looks like I'm going to be kicking out of room here. So let's see where this goes. This is going to give us the 1/2's taking off. That's going to give me y equals, looks like 1/2, minus 1/2 plus minus, that's why I like this. You could also have minus 3 over 2 and a minus 1/2, which would give us, you got it, minus 2. Be sure to put that x right in there. Sometimes my students leave those out too. And let's see if it works. Take a quick look on our graphing calculator. Let's go to it here. See what we got. Let me clear off what we got. Get y equals. By the way, in case y'all ever wonder, it's just easy clearing. It just says goodbye, goodbye. So let's put a 1/2 in there. 1 divided by 2. And put our x attached. See if we can get the x to go. There we are. And we got a minus 2. We're hoping that this is going to work. We graph it. There it goes. And now let's pop in the number 3. That was our test point. See if 3 works. Oh, got to put a trace on it first. Let's go back graph. Yeah, if you do that, that happens. Sometimes it happens. Hit the trace. You'll be fine. Now put in the 3, and let's press enter. See where we go. Negative 1/2. That is what we started with. That's what we started with. And just for the good thing of it, how about it? Does 5 and 1/2 work off? So let's check 5 on this thing. Check 5. Still on trace. Hit 5. Hit enter. 1/2 is positive. Both of the points are good. Both those points are good. So Haley, thank you for that question. The 1/2 just made it a little bit tougher. Yeah, a little bit tougher there. But you know what? That's why we're on T and Learn Mathline. We make them work for you, all right? Hey, thanks for that question. Again, from West High School today. I understand I've got another one waiting in the wings. Let's see what our next one is all about.
Hey, Ernie, I am Zane from West High School in Knoxville, Tennessee. I have an interesting math problem for you. What is the equation of the line parallel to the line 3x minus 2y equals 6 and passing through the point negative 6 and 3? Oh wait, put the final answer in slope-intercept form.
Oh my goodness, Zane, you got a lot going on here. All right, so we're going to start. Ooh, we don't start in slope-intercept form there, do we? We're starting with 3x minus 2y equaling 6. We've still got a point, negative 6. So there's an x and a y right there. So we're going to call that our ordered pair. Now, question here for everybody. That's standard form. That's what we call standard form. Remember I mentioned something like an ax plus by equals a number. In this case, a is 3, b is negative 2, and c is 6, all right? So it's what we call standard form. We need to go to slope-intercept form to find the slope, all right? So let's take that 3x minus 2y equals 6. We're going to get x by itself. No, we're going to get y by itself. Remember, it's all about y equals mx plus b, all right? Make sure y'all are awake out there. So let's subtract that 3x minus 3x, and you've got a negative 2y equaling, oh, what do we got here? A negative 3x plus 6. Now, careful. That's not a 6x, so we can't combine those. We've got to write them like negative 3x plus 6, all right? So that's the first thing got to be careful with. Let's divide now by negative 2. And watch things happen, as in sign changes all over the place there. Whew, Zane, you hit us all bases here. Everything's going, all right? So we have, the x's are gone. I've got a negative 2y, and we're going to get y equaling 3/2 x minus 3. There we go. Now remember earlier I said something about what happens when we have parallel lines? The slope stays the same. So let's go, multi-purpose. Y minus y1 equals m times x minus x1. Pop these numbers in there. We've got it. All right, we're going to have y minus 3, because remember that's the y. That's your first y, all right, equals, this one is 3/2 times x minus, and watch carefully, negative 6. Because what's going to happen there? It's going to go plus 6. It's going to go plus 6 on us. So I've got y minus 3 equals 3/2 x. Ooh, that's getting big. Play with that a little bit. How about it? 9. 3/2 of 6, that'll be 9. 3/2 times 6 is 9. We got to move this 3 out of the way, by the way, so drop that lower third and let's see what happens. We had 3, we'll add 3, and that leaves me with y equals 3/2 x plus, wow, 12 there. Is that right? Let's see how that works. That was interesting. Let's take it on the grapher and see how it works. All right, here we got it. Y equals, let's go to y equals. Quickly here, we got 3 divided by 2 with an x, and we're going to add 12. And my hope is that when we put in the point negative 6, life will be good. There's the graph. It's going to go a little bit off the page because we only have a certain amount of space there. And we're going to look for negative 6 when we trace. Got to remember to trace. And let's run in negative 6 and see what happens. I'm looking for a positive 3. Hopefully you are too. Press enter. That's where we are. All right. So that tells me that we're on the right line. We got the right point. And we have one more West High School student to give us a question for the day here.
Hi, I'm Cassandra from West High School in Knoxville, Tennessee, and I have a thought-provoking problem for you. Write the equation of the perpendicular bisector of the segment containing the points 2, 6, and -4, -6.
Boy, Cassandra, that is true. That is very, very thought-provoking. And we've got some key words that we want to cue in here, all right? It says, write the equation of the perpendicular. Perpendicular is important, and the word bisector takes a whole different meaning in this. You geometry teachers and geometry students are going like, yes, we get this. We understand this. All right. So bisector indicates I need a midpoint. I need a midpoint. Perpendicular means I need an opposite reciprocal once I find the slope. So let's go after it. That's what these 2 points will give us. It'll give us the midpoint. Let's go for it right over here. That's going to be adding the x's and divide by 2, adding the y's and divide by 2. It's their averages. They're averages. So let's do it. We've got 2 plus -4. We'll split it after we add it by 2. And on the other side, we've got 6 plus -6. We'll divide that by 2. By the way, that's going to give us -1 and 0. So we now are not going to use 2, 6 or -4, -6. We're going to go with this guy right here. That's important. Now let's go find our slope. Our slope is going to be rise over run once again. And I'm going to take it 6 minus -6 over 2 minus that -4. Now remember, we got these add the opposite moments. So we're going to put plus a positive there. And nice news is that we're going to get 12 over 6, which is 2. And that's not the slope I want to use. No. I want to use the slope that's opposite reciprocal. Change the sign, use the reciprocal. So we're going to use -1/2. So we now have a point and a slope. Let's go with it. Point slope time, folks. Let's have it out. Y minus y1 equals, you got it, slope times x minus x1. Oh, nice numbers. Thank you, Cassandra. We've got a -1 for x, so let's go with it. By the way, we know our slope is -1/2, so we've got x minus, what is it? Negative 1 over there. And over on this side, we got, oh, this is great, y minus 0. So we just got y by itself. Over here, we're going to distribute. Oh, change the signs first. All right, x plus 1. That looks like a negative 1/2 x minus 1/2. Let's go to the calculator and see if that's what we've got. All right, I've got already put in there. By the way, notice there's a negative there, and that's a minus. Be sure you put the right signs on there. Let's graph it. Well, there it goes. And let's trace. Let's see if our negative 1, 0 is what we wanted. Boy, I hope so, because we're about the end of the show, aren't we? Hit that negative 1, enter, we go to 0, and we got the right solution. Cassandra, also Jawan, Haley, and Zane, all thank you so much. Celeste White from West High School, thank you all. Knoxville West, thank you for letting us come over and videotape these good things. And folks, thank you for tuning in today.
Isn't North